I think I am live now. Before we get started, can anyone confirm audio and everything is fine? Hello everyone, today we would be discussing problems of Atcoder beginner contest 346. I was able to solve all of the problems, so I would be discussing all of these problems in sequence from A to G there. And yeah, like before we get started, I will take a minute or two to probably answer some questions in the chat. How was your problems? Like some Alok is asking, was he offline queries? Yes, we can call it kind of offline queries because like in this problem you have to start painting from the last to first, so that whenever you paint a cell you simply ignore it. And yes, D was TP. And yeah, like it would be difficult for me to predict rating range for each problem, but yeah, like you can check Kenko to find the problem's rating range. Like you can find each problem's difficulty range either on Kenko or like CList.dy also has a rating for each problem. So like that was the idea. And hello everyone. Like probably I can take it from chat. Like, do you guys want me to discuss the problems from G to A or A to G? Like whatever order like people in the chat choose, I will go with the order. Looks fine for me. I anyways want to discuss all of them. No, binary search is the intended solution for problem F, by the way. Like probably I will start from A to G only. Like a lot, like there are just two, three people. Some are two people are asking from A to G and two people are asking from G to A. And like probably in the next contest, like we have from 8 p.m. code forces contest. So next stream I will go from G to A. So yeah, this works out. Yeah. First problem says you are given n integers a1 to an, also define bi equal to ai into ai plus 1 for I from 1 to n minus 1. Print b1 to bn in the order separated by spaces. So like in this problem, we have to do pretty much what the problem statement is asking. We have to take n integers as input. Then we have to run a for loop taking from 1 to n minus 1, taking product of I into ai plus 1, ai into ai plus 1, and then print all those n minus 7 integers we had. So I directly jump onto my code for this one. So like the code is like n as input, vector a of size n, and then print like I have directly printed by running a for loop from 1 to n minus 1, ai into ai plus 1, and at last handle. It might have worked without this handle, and like this was pretty much the solution for this problem. Problem B says piano. There is an infinitely long piano keyboard. Is there a continuous segment within this keyboard that consists of W keys and B black keys? Let S be the string formed by infinitely repeating the string WB, WB, WWB, something over here. Is there a substring of S that consists of W occurrences of W and B occurrences of B? So like if we look at the problem, what the problem statement is asking us is, one second, I do not have a whiteboard here. Let me just fetch whiteboard. Okay, problem B essentially is we are given which consists like the given string is WB 2 times WB. Idea for this problem was like first thing to notice here is like the constraints here. Like constraints are between like all of them is greater than equal to 100, and it says W plus B is greater than equal to 1. So like if you notice like we do not need a string of length 200 is required. Less than equal to 200 is required. And like the main idea over here is like your original string can start from any character from here. Either it can start from here and go up to W plus B characters, or it can start from here and it can go up to W plus B characters, or it can start from here and go up to WB character 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. Like there are 12 characters. So like for example, like let's call this string as S. Then first we have one occurrence of S, second occurrence of S, third occurrence of S, fourth occurrence of S, fifth occurrence of S, and so on. Let's say if this string starts somewhere from the middle, like I am denoting cutting this string in half because like there is some starting character from here. And let's say we are completely ignoring the first occurrence. Then we can also rub it and assume it like the original string starts from one of these first 12 indexes. If you skip the first part, then you can always move back 12 characters and get the same set of string because it's infinitely repeated string. And once you notice this, then you will also realize that you need at max first 112 characters. So like we can maintain the original string S and then we can maintain a new string, let's call it T. And we can keep doing T plus equal to S, T plus equal to S as long as size of T is less than equal to 212. And once we are done with this, what we can do is like for each of the starting 12 characters, we can take the like from I to W, I plus W plus B characters, and then we can count how many times white character appears and how many times black character appears. And if it works for our given string, then we say yes. If it does not work for our given string, at last we print no. And like this was the main idea for this problem. Like the main idea is like for example, like we have this string like WB WB WWB WB WB W. Like this is the first string. Then I am repeating again here WB WB WWB WB WB. And if there is a valid string which starts from say here, and because everything repeats from here, instead of starting from here, you can also start this string from here as well. Because everything after this is same over here. And like this was the main observation for this problem. Like in contrast, I did slightly different, so I will code this problem here. Where it Like instead of 12, I'm simply taking the original size of pi. Like this is the string we need. I am maintaining a variable found. If found becomes true, I will say like I have found the kind. XP. And like this is the solution I have for this. Any questions on this one before we move to the next problem now? Okay, wait 1 second. Why is it a W? Is there a W plus B is definitely we need? Where did my sublime text go? Mm-hmm. Looks fine to me. Oh yeah, right. Like this is the size, like the number of characters you need. Like this was pretty much the solution for this problem. Any questions on this one before I move to the third problem for today? And like that was the idea for this problem. And I move to the third problem then. Okay, problem name is summation. Like this is sigma sign. You are given a sequence of positive integers a1 to an of length n and a positive integer k. Find the sum of integers between 1 and k inclusive that do not appear in sequence a. So like it says we are given some numbers a. Like first of all, we have numbers from 1 to k. And then we have been given an array a1, a2 up to an. So we have to find the sum of all the numbers between 1 to n that are not present in this array. So the one way to do it would be like we start initially assume that nothing is present from 1 to k, and we take our sum as sum of first k numbers. And like the solution for this problem was like sum of first k number we know is k into k plus 1 by 2. And once we are done with this, we maintain a set, or like otherwise we can maintain a set deleted, and we can insert all the numbers which are between 1 to k and present in a in this set, and then we remove like sum of first k numbers minus sum of numbers which are present in deleted set. And like this, these are the numbers which will not be present in the given number, and that's what we need. And like probably I will show the code for this one. Sum of first k numbers, I am maintaining a set deleted. If any number is greater than k, I simply ignore it. Otherwise, I add this number in delete it here. And what we need is sum of first k numbers minus sum of deleted numbers. And like this was the idea for this problem. Any questions on this one? Like the main crux was like a number can be repeated multiple times and you should ignore it. Okay, I will go to problem D then. I'm not really sure how to pronounce this problem word correctly, but Gomamayo sequence, let's call it. You are given a string s of length n consists of 0 and 1. A string t of length n consists of 0 and 1 is a good string if and only if it satisfies the following condition. There is exactly one integer I such that I is from 1 to n minus 1. The character I and I plus 1 character of t are same. For each I from 1 to n, you can choose whether or not to perform the following operation once. If the ith character of s is 0, replace it with 1 and vice versa. So basically, if ith character is 0, we replace it with 1, and if it's 1, we replace it with 0. The cost of this operation, if performed, is CM, and it is find the minimum total cost required to make S a good string. And like Shivam says, like he got WA on 3 test cases. I also got WA on 3 test cases. So like I think I know the case you missed there. So like if I look at the problem first, like let's first see how does a good string looks like. Like either you start from 0, you have alternative characters like this, and then you have a repeat character, and then alternative characters again. Because it says for exactly one integer, continuous characters are same. Or the other way, like other good string can be it starts from 1, 0, 1, 0, 1, 0, 1, 0, and so goes on. And probably let's say like there are equal characters here. And now like the idea is to use DP here. Like what can we say, like how can we compress this string? Like let's say if like my idea was like, for example, if we look at a string so far here, we can maintain count of adjacent equal characters so far, and like this variable should be between 0 and 1 because we need exactly one count, and we also need previous characters. So like if we know the previous character, then we have two choices. If the count of adjacent, like the if we know like the previous character is 0, then our next character can be 1, next character should be 1. Like that's the case when this we do not increase like the count of equal characters so far. Or if we want to make the character equal, then our current character would also be 0, and count of, let's call it count AJ, it increases by +1. Like the idea is like we will have alternative character always. There would be only one place where the two characters would be same. So if we know like how many times we have make equal adjacent characters so far, then if it is 0, then we have two choices for our current character. Either we flip the next character, so like the count of adjacent character remains same, or we can make it equal to the previous character, and we can also increase the count of adjacent character by 1, and we can keep going it. And like this would be our DP state. DP IDX denotes we have done some operations from string 0 to S IDX. we have a variable count integer, like the number of equal consecutive characters in this string so far. Like let's say it's one time here, although it can be technically two, but we should not go for two characters. And like previous character, or basically ith, let's call it ith character. What is this character, last character we get? And if we know this DP states, then using this we can find SIDX2, the next character as well. We would have two choices, and like if there is a need to flip character, like we can, using this we can find the expected next character. So if it's equal to like original IDX plus one character, we do not need a flip. Otherwise, we will have to add CI cost to it. And like this was the idea for it. Like there are multiple ways to do it. Like one thing is you can use a 3D DP for three characters, or you can also compress these states, or like it's even possible to get rid of, like the time complexity will always be this, but you can also get rid of this IDX character by doing it iterative. Okay, question in the chat is, why are three dimensions in array? How to find necessary state? Like these are the three dimensions in the character we have. How many characters we have processed so far? How many adjacent times? How many times we have adjacent characters so far? Like this variable would generally be between 0 and 1 because we are not allowed to have more than one character. And this would be like what is the last character we have, or like what should be the IDX character we have ideally. And like these are pretty much the necessary states for this problem. Because if you see this string, like if you probably encode it here, and like the next character should flip, next character should always change. Like the only time we are allowed to keep the same character is like we have not kept the same two characters so far right now. Like because we are allowed to have only one time two characters same. So like if we have not done it so far, then we are allowed to do it once over there. And like the reason I will show you in my code only. Like I also got a WA on 3 test cases first. Number of dimensions we have. Like these are the 3 dimensions. And like current index. Like these are the 3 states I have. The number of index I have processed so far, how many adjacent characters have been there so far, and what is the expected character right now. Or like I will call it PVR character. So like if I have processed all the indexes and my adjacent count is 1, then I don't need any operation. Like is it only one time or exactly one time? It's exactly one time. So 10101 is not allowed. It definitely needs a flip and it's not allowed. If I have not done exactly one flip so far, then I return infinite, like this is the invalid set. Now I have a DP set. I check first it in DP character, like the current index, how many adjacent count we have, and previous character. And I am initially starting with -1. So like if the current value is not -1, then I return whatever value has been computed. Otherwise, I assign it to the infinity. And like if the current index is not equal to previous index, then like this is the best state we need right now. So we move to the next state. Adjacent count remains same, and we change the like we make it like the current character we need. Or I will say like let's just flip the next character. Or I will call it current character, and I will say like it's opposite to previous character. Like I am adding this plus 0 because like it's in character form. So if SI is equal to current character, then I don't need any operation. Otherwise, I will have to add the cost here, and like my current character would be this character only because now I have flipped it once. And if ADJ count so far is 0, then I can also increase like ADJ count plus plus, and previous character, current character would be previous character. And I can do the same thing again. And like at last, I am returning whatever minimum cost I have got so far. And if I run it on samples, this passes, and like this solution will get W on exactly 3 test cases. Like I think like tourist also got W on exactly 3 test cases for it. And like the issue over here is like the place here. Like the problem is like if our IDX is 0, we are placing the first character, then like we cannot say like it's just equal to its previous character. And like the way I am running it, I have this for loop, and like I am starting with like 0, fill 0th index, adjacent so far is 0, and the character before 0 is either 0 or 1. I am running both the for loops to get the minimum over here, and like this covers all the strings I have. So like I missed out on sharing this one. Like this is the DP state over here, but I will have to start it with 0th index, 0 adjacent so far, and the character before 0 can either be 0 or 1. Both of them are allowed, so that we start from possible case, both the cases for 0 as well. And like, and because there is no character before 0, so like we are allowed to increase like adjacent count only when we go past the 0th character. And like this is the reason for W for this one. So like whoever was asking me like only 3 test cases, like wherever you are adjusting count, like you, if you increase this count, then you would be good. And yeah, like it's also possible to do it using suffix terms as well. Like you try out both the possible cases for the first character and you maintain everything and flip, and like that would also work. And like one way to do is like you can also remove this DP state and do it iteratively. Like you only need, like if you notice, to get IDX we only need details about IDX -1. So you can also try out like the similar idea which I did it in previous. I have created a video tutorial on problem E of previous Atcoder beginner contest. Like there I have introduced one technique, like how you can make this DP variable too. So like you can look at there to see like you can also reduce the space. If there are any questions on D, I will solve it. Otherwise, I will move to problem E. Okay, I will move to problem E. Problem E says there is a grid with H rows, W columns. Initially, all the cells are painted with color 0. We will perform the following operations in order 1 to m. If ti equal to 1, repaint all the cells in aith row with color I. If ti equal to 2, repaint all the cells in aith column with color xi. After all the operations are completed, for each color that exists on grid, find the number of cells that are painted with that color. And it's asking us to print like the number of different characters we have and like everything in the screen order, etc. So what we essentially need is like there we have been given a grid which looks something like this. Everything is initially painted with color 0. And then we have operations like one operation can be paint everything in this row by a given color. Then there can be another operation paint this row by a given color. And if you notice this row has been painted twice and final color here is blue here. And then there can be more operations like paint everything in this row with orange color. And in this case, like this orange color has been overwritten here. And like the next operation can be like paint like this row with purple color. In this case, like everything has been overwritten and everything is blue now. And like if you see, like it's really difficult to keep a track of what overwritten colors are there. So like I will also add numbers in the order I have painted. Like first I painted with pink color, then I painted with blue color, then I painted with orange color, and then I painted with purple color, right? So like the other way I had to do was like I have to if I paint the colors in reverse order, then I don't need to repaint anything here. Like the idea I had was I will paint colors from the reverse. So instead of painting purple at last, I will paint purple at first. And I say like all the unpainted color I had, and this is the final color here. Now I will also go for orange color. After painting purple, I will paint orange. Everything is orange now. And now I will paint blue color only in the colors which I have not painted so far. So like these would be the cells I would paint blue because like because I'm painting in reverse, whatever if had I painted blue, it would have been overwritten by purple here. And then when the turn for pink came, everything in this cell was already painted, so there would be no color with pink color. And like if you verify this, like this is same as the original grid we had. And like this was the main idea. And at last I can count like how many unpainted cell are there. I will call them like all the count of unpainted cell is 0. 0 color. And like this was the idea I had for this problem. Any questions or anything over here, like how like painting in reverse ensures that if we paint colors from the reverse, then what we will have to do is like we don't need to repaint any cell over there. And like that makes life a bit easier because now we don't no longer have to deal with complexity. We will paint every color only once, and whenever it has been painted, we will ignore it. So like any questions on this one, like why this algorithm will work before I say like how do you we count like the unpainted cell and everything. Like once we finalize this algorithm, then like we have two ways. Like I will draw the grid again. Sorry. Like the why is it working is because whenever painting, if we do it in the correct order, then we will have to, whatever color comes on each cell at last would be the final color. Like for example, if we have painted this row as orange and then we paint this row as blue, then the final color here would be blue. Like this row has been painted twice, first orange and then repainted. And my idea was like, if instead of going with this part and repainting everything, if I paint the last color, then I can avoid like this would be the latest color when this cell will come in. And now when you are painting orange, you should ignore all the repainted cell. And like this is same as previous color. Like either you paint it in the given sequence and repaint cell whenever something comes in, or you paint in the reverse order and then ignore the repainted colors. Because like when you do it in reverse order, first time you paint any color, that would be the last time that cell would be painted in the original series of operations. And how to find this logic in context, I will probably say like it would come a bit with experience. Like one famous example I will give you is like, let's say you are playing a cricket match, and whenever like the either the like like tennis match would be a better idea. Let's say two people are playing a tennis match, they play only one set and they get some points over there, and you are given a series like the character is A, if tennis or probably badminton is better idea. Let's say two people are playing a badminton match. Whoever scores 21 points first wins. And in case two people score 20 points, then whoever takes the lead of 2 points first wins the match. So if the score is 20 20 21 20 would be the next score. And then if other player scores 21 21, then like one of the player will have to score 23. So like the final score would be 23 21. Or if let's say both of them have scored 20 22 points, then one of them will have to make 24 points. Like either the first player who scores 21 points with the lead of at least 2 points win, or otherwise like scores would be more than equal to 21 points and at least the lead of 2. So you are given a valid string which says like who got the next point. Like if the ith character is A, then person A got the ith point, or if the ith character is B, person B got the bth point. You have complete string, and now you have to find the winner of that set. Like how will you do this part? Like once you think about it, like I will probably jump on to the problem E again, and once I'm done with the explanation of problem E, I will share the solution for this problem. And like this problem can give you an intuition like why this solution is also working. So like now once we know like the paint cell, like you will notice that the number of times like there are two cases like over here. Like if we look at the pink cell, if we look at the pink cell, if we look at like the way first orange was painted, purple was painted, then orange was painted. Now when we are trying to paint blue, what we need is like the number of unpainted rows, number of unpainted columns would be the number of cells for blue we have painted here. So if we maintain a count, if we maintain a count of unpainted rows so far, then whenever we are painting something on college, the number of cells we will paint is like the number of rows we have not painted here. And in this case, like total rows were 5, starting were 5. And when we painted purple, we made it 4. And when we painted orange, we made it 3. And you see like when we painted blue, like number of cells were 3. And like when we are painting pink, what we have seen is like if this row has already been painted, then we will have to skip this color because everything over here would already be painted. So like painting columns, if column is already painted, skip, otherwise count number of unpainted rows. And similarly, when we are painting column, we can do the same part. If we are painting rows, if row is already painted, skip, otherwise count of unpainted columns. And this is the way we can do it over here. So like I took a note of all the queries, I reversed all the queries. Now I am maintaining a set, painted rows, painted columns, unpainted column count, unpainted row count. And I also maintain a map which is color count, like the number of colors for each cell. Now if we have to paint a row, then if we have already painted a row, we should ignore it. Or if the number of unpainted rows are 0, then also we should ignore it. For this color, see like how many unpainted, like it should be unpainted column count. This would be the like the number of cells we would be painting right now. 1 second. Number of cells so far. We also add like current row in the unpainted cell. And like the number of unpainted row count also decreases by 1. And otherwise, if the operation is of column count, then if we have already painted, like I will call it IDX, it's better, like the index of column we are painting. So if we have already painted this column, or if there are no unpainted columns, then we should ignore it. Otherwise, for this color, we can increase the like the number of rows we will paint, and like the number of painted columns have also decreased now. And we also add it into the set of painted columns. Now we also need like zero color. Zero color would be like unpainted row count into unpainted column count. And if this number is greater than 0, then we add this color for 0 color as well. And at last we print like the size of distinct color that appears here and all in the required format. And like this should be the solution that works for this problem. Like let me simply run it for simplicity. Yes, this works. Like one thing which I forgot to mention in the badminton was like the score was valid and there was definitely a winner, and then only the game stopped. And as soon as there was a winner, the game stopped. And like this is the solution for this problem. And like yeah, before moving on to say, like I will say the solution of badminton problem. There are many ways to do it. One way is like you iterate on the complete string, count the points for each point, and at last check whoever has the highest score. Because whoever has the highest score would have, because I said it's a valid game. So like at max, it would definitely be the case that final score is at least 21 and the difference is at least 2. This is one way to it, or you can probably add some asserts to check if it's valid or not, but I am giving it's valid. Or like there is one simple solution you can do is you can simply check who got the last point. Whoever got the last point was the moment when he satisfied the condition to win, and at that moment the game won. So if the last character is A, player A has won the badminton match. If the last character is B, player B has won the badminton match. You don't have to check any of the other characters here. And like this is also the same logic which is applied in problem E. Like if you look at the last time a cell was painted, that would be its final color. And you can ignore all the colors which were on that cell before it. Yes, Jeff, it was in Erecto's interview. Like you can find it probably. I'm not sure where the channel is, but yeah, like yeah, like this is the video where Erecto mentioned this idea and like that was the one. Yes, I will move to problem F then. For a string s of length n, let f of x comma k denote the string obtained by repeating k times string s, and g of k, x comma k denotes the string obtained by times first character, second character, and up to nth character in this order. For example, if x equal to abc, then f of x comma 2 is abc abc, and for example, g of x comma 3 would be a b b b c c c. Also, for any string, both f of x comma 0 and g of x comma 0 are empty string. You are given a positive integer n and a string s and strings s and t. Find the largest non-negative integer k such that g of t comma k is not necessarily a continuous subsequence of f of n comma s. Note that g of t is always subsequence of f of s comma n by definition. Yes. So like what it says to us, like first a subsequence is like we take the original string, like we have two string s and t. We take s and repeat its copies n times, and then we have a string t. Like we have to find the maximum value of k such that when we create a string t by repeating each character continuously k times, and we have original string as repeated n times, if we delete some characters from it, we would be able to get the string t. I will show it with examples first before we move further. Like for example, in the first sample, we have been given 3 and we have been said A, B, C, A, B. So let's create 3 copies of this string. It would be A, B, C, A, B, C, A, B, C. Now we can see like G of 0 is empty string. It exists definitely. G of AB is 1 is a string AB. It definitely exists, for example, here. So the answer is true. G of AB comma 2 is AABB. It also exists, for example, if you pick this character, this character, this character, this character, it exists. And G of AB comma 3 is AAABBB. And for example, like if you take the first 3 characters 1, 2, and 3, like then only 1B remains. So like this is definitely wrong. Highest value is 2, so the answer in this case is 2. And like now, like one important property is that's called Sn as repeated n times. And let's call tk as each character 10 times. Then if there is a way to get tk in Sn, then like there for each character there would be k places where first character appears. Then there would be some random places where second character appears. and there would be some places where the third character appears 4 times, and so on. So you can see, like, if tk is present there, then tk minus 1 will also be present, because the way to get tk character is, like, for each character we just remove one of the occurrences, and you will find it. And, like, once we know this, like, so, like, now the idea is binary search. On value of k. Okay, Dimitri is asking how to determine upper bound for binary search in F. I got 3 Ws, guess they are due to lower upper bound. Oh yeah, so what I did was, like, I looked at the number of characters into Sn and divided by the size of t, and then I made some constant plus 100, something like that. So if the answer exists, like, this is the minimum number of times we require it over here, and, like, at least for me this worked over there, because, like, this would be the minimum number of characters we need, and, like, I thought, like, it would be possible there as well. Okay, yeah, right. Like, this is the maximum number of characters in the original string. Sn, the number of characters in the original string is s dot n, and, like, this would be the maximum number of times we can get each character repeated over there. So, like, this is definitely an upper bound. You can add some plus 1, 2, 3, something like that over here, and, like, this number is well within the whatever we need the set over there. So, like, this would be the upper bound. Like, we cannot definitely have these many strings over there. Like, this count of occurrences we can never get, because if we multiply it into the size of t, the number of characters would be more than the number of characters in S. So, like, we can start left with 0. Like, it's possible to get those number of occurrences, because we said, like, g of t comma 0 is an empty string, and empty string is definitely there. And we can start right with total number of characters in sz minus total number of characters in zz, like, this plus 2, like, this would be the maximum number of occurrences. Like, it's impossible to get these many occurrences over there. Now in binary search we have mid, and, like, let's say we have a black box which takes, like, g of t comma mid is present in f of n comma s. If it's true, then we increase left equal to mid, like, because, or otherwise we say, like, it's impossible to get right equal to mid, and at last we print left. So what we need is now a black box which gives us the question t comma mid substring of f of n comma s, f of s comma n. If we can somehow create a function like this which returns this as true and false, true or false, then we would be able to solve this problem, right? Any questions on the idea this so far before I move further, like how to implement this black box? Okay, like, let's look at a brute force way to print this black box. A brute force way we will do is we will maintain, like, two variables, current str count, like current repeat count of f, and current index of s where we are at it. So we will start from for x in t, for j equal to 1 to mid. Now we have two cases here. If current index has reached the last position in X, then we increase, like now we are in the next part over there. Like let's call it current repeat, like the block of S. The idea is block of X. Call it block of. Which we start with 1, we can say probably we can start with 1 or 0 wherever we want. Like this is like in which repeated block we are at. First we will process all the characters in the first repeat of X. Then we will process all the characters in second block X. Then we process all the characters in third block. If current index, like now what we can do is, like the idea would be while S current IDX is not equal to X, like the current character of T, current IDX plus plus. And whenever like this current IDX reaches the end of S, we increase S block plus 1 and like we make current IDX equal to 0. And like this is a brute force way to do it. And like at last, we return if S block is less than equal to N. This is brute force. It will definitely get a TLE, but can you see like why this solution will work? Like because like we have two strings, let's call them A and B. If you want to check if B appears in A or not, the greedy idea would be we find the first time the character of B appears in A, we should take it. Now like we check like what is the next time the second character of B appears after I have chosen character over here. Then we take that index, then we go for third index the next time which appears. And like now once we know this, like a brute force over here will definitely not work over here, because like this mid can be very large and like we cannot afford to iterate over n into size of S. So the next idea is we will make jumps, direct jumps here. Like let's say for each character in S we maintain the like positions of it. Like I will probably take the sample only, it makes life easier. Sample A is ABC. So I say like pos A is a vector which contains only 0. It contains all the characters where A appears. And now like when I am on the first character of A, and like let's just find it for G only. Like my current block would be first block, and like the next allowed index is current IDX equal to 0. Like I can take the next character from the 0th character of this block. So I will look at this vector. I can do a lower bound to find where it is over here. Like for example, like my current character of interest is these are the places where the current character I need. And let's say I need it 14 times. So what I can do is like, and like my current S block is let's say 3 and current IDX is let's say 8. Like this looks fine, right? We are on the third block of the character S, and right now we are at 8th character of S. Like we can start picking anything from the 8th character up till the end. And like the current character I need is originally at these indexes and I need it 14 times. So the idea is I will do a lower bound over here to count how many times the current character has remained. So you can see like the current character can be taken 2 more times. So I will take these characters. I will now change this 14 to 12. I will this increase this next block by 1 and I will make it 0. So like now I have picked the last 2 remaining positions in the current block. I have moved over here. And like now I need 12 occurrences. And like probably I think it's better to call 15 here. Or like let me just say like I need 16 characters. So like I have those 2 occurrences. I need 14 more occurrences. Now I am in the 4th block and my current index is 0. Now I can look how many times this appears total. Total it appears 4 times. I can make jumps in 4, 4, 4. So I make 3 strings jump to get in the 7th block. And the number of more character I can directly subtract 12 from here because in each block there are 4 strings. And now I need 2 more characters here. And now I can make like my current index jump 2 more points further. So I can say like at the end of this loop, I am in the 7th block and I can pick character from the 6th character. And like that's how I am jumping for each character. There is one lower bound call and like the size of vectors and everything. And then I can go to the next character and repeat it mid times. And like the other corner case here would have been and like let's say I need only one time. I am in block 4 and my current IDX is 8. So you see when you do a lower bound, you can look at there are 2 characters. So I don't even need a block jump over here. I can, since I need it one time, my lower bound gives me 10. So I can directly replace this character by 11. Or like the other way around, let's say I need it 2 times. I do a lower bound over here, I get 2 and I see like there are 2 occurrences here. So like I can directly replace my current block by 16 plus 1, 17. Like next character you can take from the 17th character. Sorry, like looks like I missed something here. Like that was the case when we needed block jumps. Like for example, if this is the frequency, I am at 4th block and I am at index I and I need only one occurrence. Then I can do a lower bound and I can pick the 10th occurrence and I can replace my current index by 11. Or let's say if you need 2 occurrences, then you do a lower bound, you take 10 and 16 over here and you directly jump to the 17th character. If you need 2 occurrences, you do a lower bound and directly pick 2 over here. And you don't need a block jump here. And like this was the crux for this problem. Any questions on the idea so far before I move to implementation part? Like now I can implement the things here as well. Like I have first taken all the position of all the characters in S. Now I have G and like K is the number of times I need occurrences over here. Let's say it returns a boolean. If anyway I jump past the count nth block, I will return false. Otherwise, if nothing, never ever I moved past any block, it should be fine. I iterate on the characters of S. I find all the occurrences of the current character. If there are no occurrences, then this vector is empty. I return false over here. Like I also have a binary search. If it says it's possible, I move my left counter. Otherwise, I move my right counter. And at last, I am in left. And like this is the upper bound I had. Like these are the total characters in Fn. So like if you divide by size of t, that would be the maximum number of times you can get it. I added plus 100. You can just add plus 1 or 2 to be on safe side. Like so, definitely g of f would be false. So I am done with this part. Like the only case over here is like I will also need a case here. Return to like 0 is always possible. So like let's use the terminology. I am in first block right now. I am at index 0. I am allowed to pick everything from the index 0. I do a lower bound like the next time this character appears. Like this would be the index of the value just greater than equal to our current index. This is the required number of characters we need. And like these are the number of characters that are remaining after the IDX index in the current block we had. So if our required index is less than the left index, like so like we don't need a block jump over here. We can directly jump to that index and we can call it a day. Otherwise, we add like whatever character we have got in the remaining block, and I reset my IDX to 0. Like now we can go from the next block. I have jumped to the next block so far. And at last, I will also need a check over here. Like IDX is the first index when we can pick it up. So if we have picked nothing in our current block, if we have picked nothing in our current block, then we should subtract our current block by 1 because that would be the total number of blocks we need. Like 0 is the first index we can pick over there. And like now I have moved to the next block and number of characters. Now I count like how many full jumps I need. That would be like required more number of characters I need and total number of characters in each string. So I directly made those many jumps and I required those many characters. If I do not need any jump, then I simply say like take the last time when it like if these many jumps satisfy all the characters, then I say look at the last occurrence of this character in S, and from the +1 character from there you can make jumps over here. Otherwise, you move to one more block, and your IDX would be like, since it's 0 based indexing, like if I need 5 characters, then I can take V0, V1, V2, V3, V4, and I can now start picking from the character just after it. So like this is the complete idea for this problem, and I think this should pass. Like it was slightly tricky to figure out all the details over here. Looks like I would have definitely messed up few bits left and right. Mhm. Mhm. Like when I was coding it, I had different implementation. Let's call it +1 for now. Mhm. I'm allowed to pick IDX, right? So these are the remaining characters over there. This looks fine to me. I pick everything from the current block. I move to the next block. I add counter. I can do other way as well. I can say I have 0 blocks so far, and I have add this index. Like this is fine, and this should also be fine. Like let's just add a check over here. Like the check after it will take care of. Mm-hmm. Like, can anyone check for some mistakes here? Like, I was using a slightly different modified version, like where my IDX was last used in it. So like, let me just pick my code in the contest as well. Like, where is F? Yeah, like the other way I did here was like everything remains same. Let's call it S block and let's call it last used in it. So like we have used 0 block so far and last used block is S dot size. If number of blocks becomes greater than n, I simply return. So like if I go with last used terminology, then I need S block, like the character of S which I have used. When I was explaining, I was using the character just after last block use. Like in this case, like if all the characters are present in the current string as well, then I directly make cage a complete code. So yeah, like this was pretty much the idea for it. Any questions on this one before I jump to the next problem? Yeah. Okay, I will move to problem G then. Since you are given a integer sequence a1 to an, find the number of pairs of integers L to R that satisfy the following condition. L is between L and R are between 1 to n and L is less than R. There is a number that appears exactly once among AL to AR. More precisely, there is an integer x such that one integer I satisfies AI equal to x for x between this. And we have to return the number of pairs for it. So the way I did it was, like I maintain a vector for each indexes, which is initially initialized to 0. And then I process all the indexes, all the characters. So basically the thing I am doing is I am adding 1.1 by 1 in A. So let's say I have processed 5 index so far. Then like the ith element of this vector denotes number of characters that appear in range I to 5. So the idea is now when I add the sixth character over here, like the sixth element of A6 here at the end of the day, there would be some ranges over here that would be updated. Like there would be some words, like I'm not going into specifically the details so far, but there would be some ranges where like A6 was appearing exactly once, and there would be some ranges like if we look at like the range over here, like up to A5. Like there would be some ranges where A6 was 0 times. Like now this is the A6 character. Some range where A6 is appearing 0 times. There would be some ranges where it's appearing 1 time. And there would be some ranges where this would appear more than 1 time, greater than equal to 2 times. So like at the end of the day, 6, when you update the 6, add 6 character, then these would be the updated ranges. Like this would be the where like A6 appears 1 time. Like basically all the sequences which end at the 6th index. And like these would be the ranges, starting range. Like this is starting index of a range where A6 would appear 2 times, and like this is already 2 times. Like the boxes denotes starting index. Of range that ends at 6 character and have A6 1 time, 0 time, and 2 times, more than equal to 2 times. Now you may have some A7 over here. So that's where like again the 0 time will start building up. So like if you notice over here, whenever you are adding new character at the end, there will be some range, some starting ranges which will start appearing 2 times. So you should subtract the count of characters that appear exactly once by -1 there. And there would be some range of count where like A6 would start appearing only once. So you should add +1 over there. And what you need is count of numbers which have greater than 1 at least element which appears only once over here. Like, does this make some sense over here? Like, before I go into the details, like this would be my brute force idea for this problem. Any questions on this one? Like the way I can found these changes is if for each element yes, we are trying to calculate total contribution where we fix an ending range, and like once we sum these numbers for all the ending indexes, we would be able to get it. Like for each index, maintain previous two index. So like we have an array A, 5 appears here, 5 appears here, 5 appears here, 5 appears here. So like when we are processing this element, this would be the ranges where 5 would be only once. These would be the ranges where like, or probably to put it up. Like these would be some, like let's say we are at index here. This would be the some ranges where 5 is 0 times. These would be some ranges where 5 is 1 time. And these would be the ranges where 5 is greater than equal to 2 times. So now if 5 comes up over here, these are the ranges where 5 will be 1 time. So need a +1 here. And these are the ranges where 5 was initially 1 time, now it's 2 times. So we need a -1 over here. And we can already ignore 2 because like they were already accounting for greater than equal to 2 times here. So now like I will first code a brute force idea. Like I have taken everything as input so far. I am maintaining b of size, like how many times for each character appears. So my update function is from L to R, update the character. L is an open interval. And I have a count non-zero method, which should count all the elements from I equal to 0 to I less than R. I start with the answer count as well, and I maintain the previous two index for each element. When I am at index R, I take the current value of R. I take like the previous time when A appeared and second last time. Last occurrence, second last occurrence. And then I first update this with like the last occurrence would be R and second last occurrence would be my current last occurrence for the next time. And the idea is from the last occurrence plus one to my current index, I should add plus one, because like these were the ranges where the current value was zero initially, zero times. And from like second after second last occurrence to last occurrence, I should subtract minus one, because like these were the occurrences where the current index was appearing one time so far. When I have added new character, then like everything is at least two times over here. And like since it's closed interval, I can make it open by adding plus one here. And like this is my update method. And now I have to count the number of, and like because it's also an open interval, I should count 0 to R, that is an open interval. And this works over here, right? Like this is a brute force algorithm, and it should at least give a TLE but no WA for us. Like I expect a TLE but no WA for this solution so far. And the next optimization we need is those update function and count non-zero. Right now they are running in order n, so overall solution is order n square. Like the next idea I had was like notice like the vector b we are maintaining. Like each element contain how many elements are there which appears exactly once. Notice that this element cannot have negative numbers, because it's not possible for any range to have minus one count of numbers which appears exactly once. Like it's possible to have some ranges that have zero numbers which appear exactly once. It's possible to have some ranges which have 10 numbers which appears exactly once. So like if in the segment tree range, I want to count zero, what I need is like I will use segment tree and I will maintain two things in each segment. like this is L to R. I maintain minimum element and count of minimum element. Let's say it's L to mid, and this is mid plus 1 to R. Here also I maintain minimum element and count of minimum element. If I maintain these two, then it's also possible to maintain these values for L to R. That would be if these elements are same, then add these counts, otherwise pick the one whichever is at minimum times. And at last, I will look at like from 0 to R plus R range, which is the minimum element, and what is its count. And if this minimum element is 0, then the number of ranges which have element greater than 0 would be R plus 1, like the total number, minus min count. And if this minimum element is greater than 0, then all the ranges will have element greater than 0. So I can return R plus 1 here. And like now, this was the last solution we did. So I am using lazy segment tree to update a range. Everything is initialized with minimum element is 0 and it appears exactly once. Like the minimum element is 0 and the count of minimum element is 1 for each node over there. When I want to update a range from L to R, I say L to R, change this value by R. Lazy segment tree F is the delta which I need for each element, and like this is the value for each node. So if minimum element is equal, my updated L to R would be minimum element plus sum of both the elements. Otherwise, I can say like if L dot X is less than R dot X, return L. Like here I am using like the Atcoder segment tree as a black box here. And like for the empty segment, I will say like minimum element is infinite and it appears 0 times. And this mapping function denotes like for the complete range, you should increment minimum element by R. So like that would be the case. And this composition segment denotes like you have one update of some plus L and then one update of plus R. So overall we should do plus L plus R and identity is 0. And now to count 0, I run a query from 0 to R like that. If minimum element is greater than 0, then all the segments have at least one element which appears exactly once. Otherwise, if minimum element is 0, or probably let's look at this one. If minimum element is 0, then I segment minimum element. Then like total number of segments minus how many times 0 appears, that would be the case when everything is greater than 0. And if minimum element is greater than 0, then we can do. Like I also added an assert segment. And like the same solution works here. Like let's look at our previous submission, like it's still running. On 3 cases, I think pretty much only samples were there, everything else is TLD, but that's fine. This completes my stream for today. If there are any questions in the chat, I would be happy to answer them. Okay, can you explain how to use Atcoder segment tree? What different fields mean? Or like, in fact, there is a documentation for Atcoder segment tree. Like it says we need a data structure. Like there are some algebraic definition. what essentially you need is you to need two functions. Like you first define a type as, like the data or struct you should maintain for each node. You should define one operation which takes, like, if this is the left half and if this is the right half, what should be the value for the combined segment. So here, if it's saying if you need range minimum query, then like our data type s would be an integer, because like for a given range we want to find the minimum element. So if the left half contains a as the minimum element and if right half contains b as the minimum element, total minimum from like both in L to R would be minimum of a and b. Then you should also define one function e, which should be the case for infinity, like empty segment, so that if you combine infinity with any segment you get whatever you want. So here it's saying, like, for the empty segment we define the minimum element as infinite. What I did was I changed this segment to maintain two variables, minimum element and the count of that minimum element. So if left half, like, I think the code would be more readable if I, like, if I define this s as the element. Infinite case would be minimum element is infinite and it appears 0 times. And like I will probably skip the lazy part for 2 minutes. And like this is how you can use this part over here. And when you want to use the lazy segmentary version for this library, like you define three things so far. Like the data you should hold in each segment. How do you combine two segments and the infinite value for this? Apart from that, now you need three more variables. How do you pass that lazy tag for each segment? Then you need a mapping function here, which says like this is the range and this is the lazy value you had. Now apply this to the range and give me the new output. This would be the function for the lazy part. And the composition part is, like, for some segment, like L was the first update you applied, and then you also applied an R update. So what would be the combined effect of these two updates here? So in my case, I am saying like you should apply delta for whatever range I am applying here. So like the combined effect over here, like if you want to apply this delta to everything, then because all the elements in range have increased by f delta, the count of element remains still the same. Like because every element has increased by a fixed delta, the number of times mini element would occur would remain same, just that the value of mini element has increased by delta. And if you want the combined effect of two updates in the same segment, it's equivalent to applying one update of sum of deltas required on both the segments. And this idea is like what should be the base case when you don't want to apply any update. I'm saying if you don't want any update, we should add like count was 0. Okay, Jeff is asking, how does you make sure your segments aren't counted twice for different values? Can you show the sample case one? Yeah, I can definitely dry run it on the sample case one. And like in like this was the general idea how to use Atcoder segmentary. Like first segment is 2 2 1 2 1. So I start with B. Like this will be the value for all the segments which end at index -1. Now my first element is 2, and like the previous occurrences, there are no previous occurrences of 2. So what I would be essentially doing is I would update this by 1. So now here I have, like, now when I look at all the elements up to 0th index, there is only one index and like the value is greater than 1. So like the number of index which ends at 0 and have at least one element, like this is the only range, and I add +1 for it. And like this is how my updated B is looking like. When I am done processing the 0th index. Now I add one more 2 here. The combined effect of this is like this index would be 1 and here it would be 0, because from here onwards 2 starts appearing 2 times. And then I count the number of elements in this range which are at a value greater than 0. It would be only one element, and like this correspond to this range, and like +1 for this answer. Now when I add one more at the end of this, like for all the segments, like 1 would appear only once. Like this is how this value was looking like. After the effect of 1, like this would be the count for all the segments which are exactly ones. Like now this denotes, like this 2 here denotes, there are 2 elements in range 2 to 3 that appears exactly once. 2 elements. And what I am looking at is like all the elements which are greater than 0. So like this third index, the value is 1, which is greater than 0. So +1 for it. This value is 2, which is greater than 0. So like this is the valid range and I should do +1 for it. And 0, 2, like this value is 1. So +1 for it. So like, because I am only counting the number of, I am not taking the sum of B over here. I only need like number of values in B which are greater than 0. And like that's how I am avoiding this double counting over here. Because when I run a query and I count the number of elements greater than 0, I will get 3. But the sum of elements is 4 here. And like this is the idea over here. I can run it for the next values as well. Or I can probably avoid it if I think this clears the answer. And like that is the idea. Any other questions over here? And like one of the reasons I recommend doing people Atcoder beginner contest a lot is like it tries to repeat some ideas and like something which you have not seen so far. Like if you ask me personally, I think I have seen like the paint repaint idea. I have seen it before. I think I have definitely seen this string and string idea somewhere before over here. And even in the case of alone, the idea of how do we maintaining the minimum and the count of minimum to find something, I think I have seen it before. And like this is one reason, like if you are starting out, you should definitely do Atcoder beginner contest, because you will definitely learn one or two new ideas when you solve it when you are starting. So any questions from the chat? Any other questions related to probably Atcoder problems or something in general? Like I would be happy to answer them probably for 2.5 minutes, and then I will call it a day when it's around 9 p.m. in India. Thanks everyone for joining today. Like I will add timestamps over here, so like whoever did not join, they would be able to directly jump on the problem for that. So thanks a lot, and see you next week. Probably I am planning to do lead code sim tomorrow morning, and after that, like I will definitely do ABC stream the next month. But although like the next ABC classes with code forces on, so I will do only it for 45 minutes and try to cover as many problems as I can. So thanks everyone for joining today, and I had a fun time discussing the